to a new video. Today in this video we are going to do 2 exercises in an inclined plane. But first, we have to remember and think what formulas we are going to need. In these 2 exercises we are going to need 2 formulas. The first formula is sigma fx is equal to m per a, mass per acceleration. And the second formula is sigma fj equal to 0. So, the first step is confirm all the data. The second one is draw a model. And we can forget the step 3, make a free body diagram. And the step 4, write the forces in polar coordinates. And the 5th step, use the formulas. You have to remember, the first formula is sigma fx is equal to m per a, mass per acceleration. And we have to use always the second one. Sigma fj is equal to 0. And the 6th is clear for n. And the last step, substitute the n to obtain the acceleration.
Hello everyone! Today we are going to do some exercises in our inclined plane that we built in class. So get ready and I hope you learned something new today.
For our project we're going to have an inclined plane. We have a half kilogram weights, a 1 kilogram weights, and a 2 kilogram weights. We have a 30-degree angle. When we place this one in here, we put the 2 kilograms up, and we're going to be pulling down. And the 1 kilogram going up, the major force we're going to be going downwards. Which we're going to finish by pushing this away.
Alright, so now we are going to do the calculations, corresponding calculations for our exercise now in paper, so that you can obtain a normal force and acceleration. So we are going to write the data we already have. So F1, we have a 2 kilogram object that was pulling. So in this case we have 18.6 newtons. As force number 2, we have one of 1 kilo, so it is 9.8 newtons. We know that the mass, as I already said, so it is an object of half a kilo. We are gonna have a friction of 0.12, and finally the angle, it's gonna be 20 degrees, as we already did in our exercise. So now we are going to, first of all, represent all of these in a drawing. So we are gonna do our inclined plane like this. It's gonna be a triangle. We are gonna place our object 0.5 kilograms, and now F1 is acting going down, so we have F1. F2 is going up, and as you can see, F1 is bigger than F2, so the object is going downwards. So the friction is gonna be going going always opposite to the movement of the object. So we have here represented as mu k, and then we have 2 more forces: the normal force always going up, and the weight that is going down. So we already have here the drawing. We are going to now do our free body diagram. So we have 2 different possibilities here. We can do it like this, which is like it's not the proper way, because both of them are the same, but it's the way that represents really like the inclination the inclined plane has. So we are going to have our second possibility, that is this one. So this one is like the normal free body diagram that we were using before. So now we are going to represent all the forces using I'm gonna use this one because it's the one that, yeah, is gonna help us understand a little bit better. We have our x and our y, so we're going to write the forces. So we have F1, we have F2, we have mu k, we have normal force, and here is the interesting part because weight, as you can see here, is going down. Weight. So right now, if we like turn this one, you are going to have this one that we were using. So we're gonna put here the W, and finally the angle. So the angle is here, 20, and it is this one. But as you can see, this is it's like a triangle cut at half. So we have two angles with 90 degrees as the angle here. So this angle is the very same than of this angle, so this one is the same as this one. So we always put here, 20, the angle like in between the weight arrow and 270 degrees. So this is it. This is our free body diagram. Now we are going to write in polars the forces that we have. So remember always to put the arrow in polar. So we have first 18.6 newtons, and the direction, as you can see, is 180 degrees. F2, we have 9.8 newtons, and the direction is 0 degrees. Now we have weight. So remember, mass is not the same as weight. Mass is using kilograms and weight is using newtons. How can we know that? So you always multiply the kilos times the gravity. So 0.5 times 9.8, which is 4.9 newtons. So we have that our weight is 4.9 newtons, and it's going in this direction. So it's 270 degrees minus 20 degrees, which is 250 degrees. Now we have mu k, which is going to be our friction. So we have that is 0.12 times normal force, and the direction is going to be 0 degrees, the same as F2. And finally the normal force, which is going to be normal force and 90 degrees, always 90 degrees for normal force. So we already have our polars, we have our free body diagram and the representation in here. So finally we're gonna do our calculations. Remember that we are searching in this problem for normal force and acceleration. You need the normal force for acceleration, so yeah, they are related there. So we are gonna do our calculations. First, we need to remember that sigma fx is always equal to mass times acceleration, and sigma fy is always equal to 0. So knowing this, we can already do our equations. Fx, and remember you always use cos and sin. Cos for x and sin for y. So we are gonna write 18.6 newtons cos 180 degrees, 9.8 newtons cos 0 degrees, 4.9 newtons cos, sorry about that, always try to put it together so you don't get confused, yeah, like in the same line. And finally n cos 90, and this is equal to MA. So now I'm gonna do all the calculations for this one, and I will be back with sigma fy. Remember, it's the same but with sin. So alright, so we already have both of our calculations here with cos and with sin. So first we're going to start with the y, because we have here n, and as you can see it is alone, so we can clear this equation and obtain n. So we have that n is equal to 4.6 newtons. So now we are going to substitute this n here and multiply it times 0.12. So 0.12 times 4.6, that's 0.552. And yes, we are gonna minus 10.48. Alright, so we have here that 9.93 newtons. This is equal, so this is equal to MA. We are gonna pass M here and leave the A alone. So M, remember that M is 0.5 kilograms. It is not this one. So M is with kilograms. So this is divided by 0.5 kilograms. And we are going to obtain our acceleration after doing that. So 9.93 divided by 0.5 is equal to minus 19.86 meters per second. So this is the final results of our acceleration, our normal force. We are gonna write them right here because for you to know, 19.86 meters per second squared, and normal force equal to 4.6 newtons. It is normal for us to obtain a number here in acceleration that is negative because the movement, as we said, is going downwards. So yeah, that was it. Thank you so much.
For this example, we're going to have a 20-degree angle. We're going to have a force of 1 kilogram going downwards and one force of 2 kilograms going downwards. But because of the pulley, it will going to be like inverse, so it's going to be upwards. So when we let it fall down, it's going to be pushed up. It's going to be pushed up and we're going to be moved.
Alright, so now we are going to do the same thing that we did before, but now with a different, a different form in which we can put our inclined planes. So we have the same numbers as we did before. F1, we have this one, F2, it's gonna be 9.8 newtons, the mass of 0.5 kilograms, the friction 0.12 because it's the same surface, so that doesn't change. And this time the angle is gonna be a bit different, so now we're gonna have an angle of 10 degrees. It's not gonna be 20 as before. So right now we're gonna do the representation in here. So we have the inclined plane as we had before, but this time we have an object pulling downwards. So in this case we have here our 0.5 kilogram object. We have in this time the forces in a different way because 18.6, like the F1, is now going alright, so it's basically pulling the object downwards instead of upwards. So it's gonna have F1 here, we are gonna have F2 going down, we're gonna have weight going down, we're gonna have N, and as always mu K going here as before. So yeah, now we're gonna do our free body diagram. So we're gonna do like this. This time I'm gonna do it this way for you to understand it in the other way. So we have our object in here, normal force going up. We have, alright, so if you see, F1 is going downwards this time. So F1, and weight. We also have F2 and mu k. So if you see the problem that already presented, Esteban already presented, we have the object in here. There is a pulley, and this one is pulling downwards. This one is pulling like this. That's why I put the weight and also the force in the same way. So it's the same. We need to write the forces and then do our calculations. Alright, so I already made the calculations. Now we are gonna do the same as we did before. We're gonna clear n, and we have like this. And now I'm gonna substitute this one here. So it's gonna be minus 4.19 minus 0.12 times 23.16. Alright, so we have minus 6.97 newtons divided by m, which is gonna be 0.5 kilograms. This is gonna be acceleration, and we have I'm gonna do the calculation. Yeah, and the result is this one, 13.94 s squared. So we put here the results. I'm gonna put them up here. So it's going to be n equal 23.60 newtons and a equal minus 13.94 meters per second squared. So these one are the final results of the second problem and last problem.
So in this example we can show how the different forces act, and when you have a major force versus a minor force, it's going to be in the direction of the minor force.